Welcome to the LMWC Learning Mathematics with Ms. Choekyi channel. Please do hit the like button and subscribe the channel.
Hello everyone. So today we are going to start the exercise 1.2 of chapter number 1, real numbers. So the first question we have, prove that root of 5 is irrational. So to prove this, we are going to use the contradictory method. So let us all prove together. First we will write prove. So let the given question square root of 5 is, the opposite of irrational is rational. So now we are going to apply the definition of a rational number, which is a rational number can always be represented as a by b, where a and b are integers and b is not equals to 0. And here we are going to assume one more, that is a and b are co-prime. Okay, so always mention this co-prime. This is very important to prove this root of 5 as irrational. Now we are going to take the cross multiplication, so this will become root of 5 times b equals to a, and now taking the square on the both side, this will become 5b square equals to a square. Since root of square root and the square will get cancelled, so this will become 5, and this square also belongs to b, so this is b square. After that, we are going to take the b to the denominator of a square, because we need to prove that root of 5 is indeed an irrational. So now here what we have got is a square by 5, which means that 5 divides a square. And we know from a theorem that if a prime number divides a square, then that prime number has to divide the number a. So for that, you can just mention it like this. We know that if p is a prime and p divides a square, then p must divide a as well, where a is a positive integer. So always you have to mention the theorems. So whether so I have written it this way, you can elaborate in a much better way. So this will be your first equation. So in the first equations, we have shown that the number 5 is the factor of the of our a. So the second equations, we have to show that this number 5 is again the factor of b, so that will show that a and b has a common factor number 5, which will contradict this co-prime, and hence we will just say that our assumption is incorrect, so it cannot be rational, rather it has to be irrationals. All right, so let us do the second equation. So for that, you have to assume a is equals to 5c, where c is a positive integer. So now we are going to square both the sides, so that will become a square 5c whole square. So a square, we know from here that a square can be written as 5b square, which is equals to 5 times 5 is 25, c square, so 5 times 1, 5 times 5, so here we are left with b square equals to 5c square. Now if you take this 5 to the left hand side, that will go down in the denominators. So this is what we need, and we have got it. That is, if 5 divides b square, then 5 must divide b as well. So that is our second equations. So from 1 and 2, what we can conclude, 1 and 2, we can conclude that we know, or we have, a and b has a factor, common factor number 5, and this contradicts a and b as a co-primes. And this contradiction arises So these contradictions arise due to our incorrect assumptions. Hence, root of 5 can be concluded as irrational. Hence, proved. So this is how you have to prove such kind of questions, whether it is root of 5 or root of 2 or root of 3, root of 7. So all those irrational numbers, you have to prove it in this way. All right, moving forward to the next question. So next question, we have a little bit of a different number. So here, although we can see a root of 5, but along with this, we have some other numbers. So we have 3 plus 2 root 5. So this we have to prove as irrational. So again, always the contradictory method, but it will be a little bit different than the previous one. So let 3 plus 2 root 5 is rational. So using the definition, so 3 plus 2 root 5, we can write it as a by b. So a and b are integers where b is not equals to 0. Now, what we are going to do is we are going to split this 3 plus 2 root 5. We are going to write only the square root 5 on the left hand side, and 3 and 2 we are going to take it to the right hand side. So what happened here is, first I will take this 3 to the other side. So this 2 root 5, it will be as it is. And over here on the right hand side, a and a by b, there will be no changes. Now since we are taking this 3 to the other side of the equality, what will happen is this 3 and this 2 root 5 has been differentiated by this plus. So now what happened is this 3, when you take it to this side, you will just need to change the sign of the 3. So here before 3 is nothing, means it is positive. So when you take it to other side, this will become a negative 3. Okay, so now next is we have to take this 2. We don't need this 2 here. We need only root of 5. So root of 5 equals 2. So when you take the 2 to the other side, now this time it will be different. So here 2 and root 5, between them there is nothing, there is no plus or no negative, which indicates between them there is a product signs, multiplications. So whenever you take a product number to the other side, that will become a division. So opposite of multiplication is division. So here what happened is, when you take the 2 to the other side, that will go in the denominators. So already we have a by b minus 3 in the right hand side. Now if I take the 2 to the other side, what will happen is, you just need to put a bracket in this. This will go in the denominators. So denominator will be 2. Numerator, we do not know anything. So it will always be number 1. So just write it as 1 by 2. Okay. So after that, now if you look carefully, irrational numbers, root of 5, so on the left hand side we have only square root, while on the right hand side we do not see any square root here. So all the numbers, if you look carefully, all are integers, right? So here at this time, what we are going to do is, left hand side we have root of 5, which is actually an irrational number, isn't it? Whereas on the right hand side we have this number 1 by 2 times a by b minus 3. Now if you simplify it, what will happen is, this a by b is a rational number, 3 is also a rational number, because 3 we can write it as 3 by 1. So rational number and rational number, when you subtract it, the answer will always be a rational number. And a rational number times rational number, if you take the product, answer will always be a rational number. So this whole right hand side is a rational number. So what we have just got is that root of 5 is equals to this, which indicates that LHS is equals to RHS, right? So what we have just got it from our proof is that LHS is equals to RHS. But if you look carefully, LHS is irrational, whereas our RHS is rational. So irrational and rationals, definitely they are not equals. So now here, this is the contradictions. One, it is stating that LHS and RHS is equal. The other is stating that they are not equals. So this contradictions arise, again same, due to our incorrect assumption. So we need to correct our assumption, and that is 3 plus 2 root 5 has to be irrational. So with this, we are done with the second question. So the next question, prove that the followings are irrational. So in the question number 3, we have few sub-questions. The first one is 1 by root 2. We are going to prove this as we have done it in the question number 2. So we'll let 1 upon root 2 be rational number, implies 1 by root 2, I can represent it as a by b, where a and b are integers with b not equal to 0. So now what I'm going to do is I'm going to take a reciprocal of this. So 1 upon root 2, it will become root 2 by 1. So denominator 1, no need to mention it. So a by b will, if you take the reciprocal, this will become b by a. Now what happened is, this left hand side we have root of 2, and the right hand side we have b by a. So root of 2 is irrational, and b by a is a rational number. So we have a contradiction. And this contradiction arised due to our incorrect assumption. Hence, 1 upon root 2 is irrational. Hence proved. Alright, moving forward to the next question, 7 root 5. So to prove this, let 7 root 5 be rational number, implies 7 root of 5, I can write it as a by b, where a and b are integers and b is not equal to 0. I just need to take the 7 to the other side, so this will become a by 7b, because 7 and root of 5 in the product form, so this will go down in the denominator. So here we have LHS, which is root of 5, is irrational, and RHS a by 7b, it is rational. So we have a contradiction, and this contradiction arised due to our incorrect assumption. Hence, 7 root of 5 has to be irrational. Alright, so the next, again, we have one more sub-question. So that is 6 plus root 2. So let 6 plus root 2 be rational, implies 6 plus root of 2 is equals to a by b. Always mentions what are a and b. So a and b are integers, and b not equal to 0. So separating the rational and the irrational on the left hand side. So root of 2 is equals to a by b. So 6 is a positive number. This will become negative number. So LHS equals to root 2, which is irrational, and RHS is equals to a by b minus 6, which is rational. So hence LHS is not equal to RHS. So these contradictions arise due to our incorrect assumption. Hence 6 plus root 2 is irrational. Alright. So with this we are done with the chapter number 1. So we are covered up all the concepts, examples and the exercise questions of the chapter number 1 as per the NCERT 2025 batch. So thank you so much, and please do hit the like button and comment and share my channel with your friends, and thank you.